Hey guys, welcome back to the channel. Mr. Wiz here. If you are new to this channel, we build video games. So right now, we are working on a Unity course. We've been spending a lot of time on this. We've been learning a lot of great skills about building games in Unity. In fact, we just finished our first game. We made a flying game where we wrote the C# scripts to control the plane, and we created some overlap code. So when the plane collected coins, you got points, but if it crashed into things, it would end the game or it would restart the game. So that was the last game that we made. Now, I decided to change things up a little bit because everything we've been doing so far in Unity has been in the 3D version of Unity, right? But Unity does a lot more than 3D programs, 3D games, and the like. You can do stuff in 2D as well. Now, when I talk about 2D in Unity, I just need to clarify real quick. You can build a 2D program with a 3D world, okay? So basically, what I mean by that is you could build a game that uses 3D models, a 3D world, and have the camera basically be the 2D element, right? So the camera views everything two-dimensionally. So in other words, it would be like a top-down game, right? Where you might have characters running around, you may have them shooting zombies or doing something else, but the camera stays above you the whole time, looking down, and creates a 2D vision, a 2D view for the player, right? So you can build 2D games that way, where you're still working in a 3D world, but the player sees everything from a 2D perspective. That is not what we're going to do. We're going to do a true 2D. So what I want you to do with me is I want you to go ahead and get into Unity Hub and say that you're going to create a new project. And we're going to select the one that says 2D. We're also going to do a mobile game. So we're going to go 2D mobile. There is 2D core, but I decided since we haven't done any mobile games yet, I might as well kill two birds with one stone, and we're going to do a couple new things in this project. We're going to do our first 2D program, and we're going to do our first mobile program. So instead of doing 2D core, we're going to do 2D mobile. Now, I'm doing the 2022 version, but this should exist in pretty much any Unity version. So if you're doing one of the older ones, like the 2021, which I have a lot more experience in, you'll notice 2D mobile is also there, right? So 2D mobile exists in different versions. I'm going to go ahead and name this. What do I want to name this? I'm going to name it Asteroids, because I will be basing this game off of a project similar to the one we did in the MakeCode Arcade course. If you didn't take my MakeCode Arcade course, where we did stuff with JavaScript and block code, it's a lot of fun. But we built an asteroid game there, a 2D asteroid game. So the game we're going to make in Unity is going to be kind of similar. It's going to take a lot of inspiration from that game. All right, so we're going to go ahead and create this project. Okay, so my program is up. Clearly, I fast-forwarded through the part where it was building it because that does take a little bit of time. But here it is. I'm looking at it now, my mobile 2D template. So I've got my scene view. I've got my game view. Right now, I do have my layout set to default. We may customize it more later, but this is a good place to start. So first thing I am going to do is I am going to change the name of my scene. I don't like to leave scenes called sample scene because that can cause problems later on. So let's go to my scene folder and let's just go ahead and rename this. What do I want to name it? I'll just call it Asteroid, like I named the game. It doesn't really matter. The name of the scene isn't important. The main reason I'm changing the name of the scene is just so that if I do end up downloading something that has a sample scene, I don't lose my work. It doesn't replace the sample scene that I already have, right? Although in honesty, in this project, I don't expect to do a lot of downloading. I know we've been doing a lot of stuff we've been downloading from the asset store. I don't plan on doing much of that in this project, and I'll explain why in a little bit. So right now I've got my scene. The only thing in it is the camera, and there you can see it, and here you can see the border for what the camera sees. Obviously, this is a 2D game. We don't have much in it yet. We haven't put anything in it yet. My camera view just looks like a blue screen. That's what I have right now. I don't even have a background yet. So that's the background, it's just that blue screen. Okay, so being that this is going to be a mobile game, I have my first dilemma here. Because right now, the camera's window is actually based on the size of my windows, particularly my game view. So what we're seeing here is the size of my game view. I can make it square. I could make it more rectangular if I wanted to, which would kind of look more like a cell phone. Here we're starting to get kind of the cell phone shape, but that's not practical, okay? I guess I'll just switch back to default. Boop. Okay. So, yes. I want my screen to actually resemble the screen of a phone. I don't have my phone with me, but typically if you're playing a mobile game like the type that I'm planning on building here in a moment, you're going to be playing it long ways. You're going to have your phone this direction, right? In the vertical direction. And you'll be pushing buttons down here, and I want a ship that goes left and right, and there's going to be asteroids or something coming down from the top of the screen that I'll be shooting at. That's the type of game that I'm planning on building, right? So my layout should fit the phone, and right now it doesn't. So we're going to take a little extra step before we start coding anything. I want to make the layout correct for a mobile device in the vertical perspective, okay? All right, so if I go to Game View, here's something that we've never talked about before. You can change the perspective of your game view, and there's a few different ways to do it. Right here where it says free aspect, I can click on that, and I can actually set an aspect for my game view. So 16:9 is pretty good if you're doing a horizontal game, or you can create your own aspects down here. Hitting the plus sign, you can create your own. So I actually created one that was aspect ratio 9 and 16, and I called that phone. And I've actually already done it, which is why you see it right there. So I'm just going to cancel this. So this is one I've used before when I wanted something that actually looked like a phone perspective. And this works pretty good, but we can go even better. Unity, the newer versions of Unity, have a simulator built into them. So over here where it says game in my game view, I can click on it and I can click on simulator. And I can actually pull up different devices. And when I set these different devices, if I go back to scene view, the layout matches the device that's in my simulator. So if I'm using a tablet like this one, my layout matches my tablet. If I go to the Google Pixel, my layout matches the Google Pixel. So if you're using a newer version of Unity that has the simulator already in it, you can switch from the regular game view to the simulator game view, and you can actually test your games as though you were playing them on that device. You can actually see the mobile version of your game. Pretty cool. Now, what if you're using one of the older versions, like the 2020 version, which I'm very fond of? I've used it quite a bit. It does not have this pre-built into it, but you can download it. So just to demonstrate what it might look like on an older version of Unity, this is the 2020 version, which, like I said, I'm a little bit more familiar with. And if you notice in the Game tab, there is no button to change from game to simulator, right? There is the option to change the aspect ratio, like I already showed you, but there's no option to change the simulator. So here's how you would get the simulator on the 2020 version or similar versions. You would go to the window, you would go to Package Manager. You would have to make sure Unity Registry is selected. If you're in Projects or My Assets, you need to switch it to Unity Registry. And then what you're looking for is called Device Simulator. But the Device Simulator was not designed for this version, so it actually does not show up on the list. If I want to use it, I have to click on this gear icon next to the search bar, select Advanced Project Settings, and down here, there's an option to enable preview packages. I have to turn that on. If I enable preview packages, that allows me to see packages that aren't necessarily designed for this version, but may still work. So we're going to enable preview packages. Now when I go back to my Unity registry and I look for Device Simulator, there it is. And you can see here that it is a preview version. All right, so we're going to go ahead and install the simulator on the 2020 model. And it looks like it's already, oh, no, it isn't. There it is, it's installing now. So this hopefully won't take too long. There we go, it looks like it's already done. So I'm gonna go ahead and close that. Now in my game view, I see the simulator option. Here, let me switch this to default layout because I'm using an old layout right now. So even in default layout, I can go to game, and now that I've added it, now that I've installed it, I can see that where it says game or simulator, and I can select the device. And when you go to scene view, there it is. So whatever you're using in the simulator, the scene view will mimic it. It will copy it. And this is going to be very useful to you as you're building your game. Yep. All right. So enough about that. Let's start building our game. The first thing we're going to do to build our game is to build our player and to give him working controls. So as I already mentioned, I'm planning on making this game a asteroid type game where there's going to be objects falling from above and you have to shoot at them, and the player will be at the bottom of the screen. So I need to go ahead and create a player. So here's where I love building 2D games in Unity. You don't use 3D models, which means you don't have to go digging through the asset store trying to find a good 3D model. Since this is a 2D game, you are using sprites instead. Sprites, if you're not familiar with that term, are basically just 2D images that you can code to be interactive. So any 2D picture, any regular picture, can be used as a sprite in Unity. I just need to go find a picture that I like or create a picture. If I'm artistic, I might draw one or paint one with a paint program or some sort of, canvas or something like that. There's lots of tools that you can use to design and build your own pictures, right? Or I could just go find one on Google. There's always that option. Maybe I want to use AI and have AI help me design the picture. That'd be kind of cool. So you have that option. But any 2D image can be used in my game as a sprite. So go take a moment and find what you want to use as your spaceship. Maybe you're going to find it on Google. Maybe you're going to make it yourself. Don't take a long time on it because I have more I want to show you in this lesson. But go find your image and then come back and I'm going to show you how to put it in your game. All right, so I found an image that I want to use for my ship. However, it had a background to it. To look good in my game, I did have to remove the background. I do recommend doing that for your sprites. You don't want them to be all boxy and squared. It won't look professional, right? So definitely remove the background. If you need help doing that, there are websites like remove.bg that you can use. Adobe has a background remover. There's a lot of free websites out there with background removing tools that you can use. So I've already removed the background from my picture. I'm going to go ahead and put it in my game. To keep myself organized, I'm going to create a new folder. And I'm just going to call this folder Sprites. And that'll give me a nice little area where I can keep my sprites in. All right, so I'm going to right-click and import. And there it is. I just imported my asset. And I've already removed the background like I said. And to put it in my world, to put it in my scene, keep in mind, this white box represents where the game's going to be, right? Oh, let me just double check. My main camera position is at 0, 0, -10. That's fine. Position's good. If your X and Y, for some reason, aren't 0, 0, I would definitely change that. But yeah, so here's my stuff. I'm going to go ahead and put my sprite into my game by dragging and dropping. So there it is. Obviously, it's way too big. Also, it's crooked. It's diagonal. I don't want that. So let's go ahead and start editing it. With my tools, there is a tool that I haven't really used in front of you guys before. But you've got the moving tool, you've got the rotating tool, you've got the scale tool. Down here, the last tool on the set is kind of a multi-tool. It allows you to do multiple things at once. I don't use this very often when I'm building 3D games because it tends to get in the way. Usually I am only trying to do one thing at a time. But with sprites, the transform tool they call it, this multi-tool, it's very useful. So in this case, I'm going to go ahead and rotate it with the blue circle. Try to get it pointing up as best as I can there. There we go. And then with the middle box, I can grab it and I can adjust the scale of the object. I do want it to be a lot smaller. Let me zoom out a little bit. And then with the arrows, I can move it down to the position that I want it to be at. So right there around the center, bottom of the screen. And there we go. Looks pretty good. We've got my little spaceship at the bottom of the screen. He's the right size. He's the right position. He's the right rotation. Everything looks great. All right, so let's go ahead and start coding this guy. So I'm going to go back to my assets. I'm going to create a new folder for my scripts. And I'm going to call this first script player controls. There we go. Make sure you name it when you create it. That's the easiest way to go, because if you rename it, remember, if you rename it after you make it, you have to go back into the code and you have to rename the public class as well. They have to match or it won't work. All right, so I got my ship. I've got my player controls. I'm going to go ahead and drag and drop it onto the ship. There we go. Now let's start writing the script. Let's give it controls. The way I want my program to work is I want the ship to be able to move left and right, but I don't want him to move up and down, so just left and right. Also, because this is a mobile game, his left and right movement will not be based on the arrow keys on the keyboard. Think about it. If it's a mobile game, you're holding your phone in your hand, how am I going to control whether he moves left or right? It's from me tapping the screen. So how do I control whether he moves left or if he moves right? Think instinctively. If you're playing this game, I'm holding the phone in my hand. If I tap on the left side of the screen, he should move left. And if I tap on the right side of the screen, he should move right. So really, what I'm going to be measuring to get him to move is the position that I'm tapping. Where am I touching the screen at? That's what we're going to be looking at, okay? So we're going to do this using some logic, using some positioning, and we're going to go ahead and get started. So here's the code that we have so far, and we're going to be putting most of our code in the update section because it needs to read this logic with every frame update. It needs to know, am I touching the screen? And if so, where am I touching the screen, right? So there's going to be a lot of logic in this. We'll go ahead and get started. If. Remember, whenever we use if, we put the condition inside of our parentheses. And then after that, we have a set of curly brackets where we put the action that we want to happen. So we want it to be checking where we're clicking on the screen, but we want it to check that when we click on the screen. So we're actually going to have a condition inside of a condition. The first one is saying if we touch the screen, and the second condition is going to be depending on where we're touching the screen. So if get mouse button, and we put another pair of parentheses there with a 0 inside of it. So basically what this means is if you click the mouse, which in this case, clicking the mouse is clicking the screen, okay? Oh, I forgot input. If input.getMouseButton. All right, there we go. So if input.getMouseButton, parentheses 0, which means that we're actually pressing the button here. All right, then what do we want to happen? We want it to check the position of the mouse. So we're going to put another if here with another curly bracket. So we have an if inside of an if. All right, so if the button is pressed, now this one's going to be based on the mouse's position. So in order to know the mouse's position, we're going to go ahead and create a new variable. Now this time we're going to put the variable inside of this logic block. Normally, when we've been doing variables in the past, we've put them at the top of the program before the void start up there because we've had the variable getting created at the beginning of our program. Now I want the variable to get created when I tap the screen. So when I tap the screen, it needs to save the position information of where I'm tapping it. All right, so when the button's pressed, we're going to create a variable. It's going to be a vector3. And it's going to be called, why did I put a space there? Vector3, we're going to call it mouse POS for position. And it's going to be equal to input dot mouse position. So when we click on the screen, it's going to save this variable called mouse position, a local variable. You'll see it's describing it there. It says only in this part of the code. So it's going to save the mouse position information to equal whatever the mouse's position actually is, right? So it's saving the X, Y, Z values for that. So now we're going to check this down here. So if the mouse's position, specifically its x position, so we're going to do dot x. So if the mouse's x position is, and here we have to decide how we want this to work. If we're tapping on the left side of the screen, we need to go left, and if we tap on the right side of the screen, we need to go right. So how do we decide whether it's clicking on the left side of the screen or the right side of the screen? We're going to do a little bit of math here, nothing too crazy or complicated. So if it's on the left side of the screen, it needs to be less than the screen dot width divided by 2. So the screen width is the total width of the screen. Dividing it by 2 cuts it in half. So we're basically saying if it's less than half the width of the screen. So if it's on the left side of the screen, that's what this is doing, right? So if the mouse's x position is less than the screen width divided by 2, then we want it to move. We want it to move to the left side of the screen. We need it to move to the left. So we're going to create our position moving thing. And this is the part that's kind of similar to the movement controls we've done before, right? So we're going to have the transform dot translate, just like we did with our last program. And then we got to tell it where to go. We're going to go vector3 dot left. Remember how we learned about our vector3 dot up, dot down, dot left, dot right? So it's a little bit of a shortcut, right? Vector3 dot left tells it to go to the left. Now, how fast we want to go to the left, that's really up to us. So we're going to multiply it by whatever number we want to use for the speed. We should probably come up with a variable for that, actually. So let's come up with a variable for the speed. Up here, before the start, let's create a public variable that we can change inside of Unity. We're going to make it a float or an integer. Let's do float. That way you can use decimals if you want to, right? If you want to make a speed of 2.5 or something like that, you can do that with float. You can't do that with integer. And we'll call it player speed. Semicolon at the end. All right, so I just created a variable called player speed. We'll use that here. Player speed. All right, so we're going to have, if you tap on the left side of the screen, you're going to go left at the speed of the player, and then don't forget, this is per frame, right? So which will be way too fast. If we need to be more realistic speed, we have to make sure we multiply that by time dot delta time. Remember us learning about that? So now he'll move left at the speed that we gave it, and instead of doing it per frame, it will be doing it per second. All right, this is a lot of coding we've already done, so before we worry about the right side of the screen, let's just test this out and see if it works. Control S to save. Let's go to our program. Okay, I did get an error message. Semicolon expected. All right, I forgot my semicolon. I do that all the time. Yep, there it is right there. I remembered it up here, but I forgot it down there. All right, let's try this again. Control S. There we go. No more error messages. Let's get into play mode. And if I click on the left side of the screen in my simulator, it should move to the left. Let's see what happens. Nothing. Nothing's happening at all. Did I forget something? Oh, I am forgetting something. I forgot to set the player speed. Let's look at the sprite. Player speed is set to 0. Ha! All right, let's increase that. Let's set it to 5. Let's see what that looks like. Let's try it again. Click on the left side, and he does move left, but you notice he's moving left and down. Did you guys catch that? He's moving left and down. There's a reason for that, but before I go into it, let's just fix up the right side. So we're going to copy this whole thing. Control C to copy. And I'm going to create a couple extra lines after it. Watch out for these brackets. Make sure you're not putting stuff after the brackets that you're supposed to be before the brackets and stuff like that, right? So I copied that whole code, and then I pasted it right afterwards so that I could do the right side of the screen. So instead of doing less than, I'm now going to do greater than. And instead of left, we're going to switch it to right. Okay, so let me save that. Here we go. Okay, so now if I test it, if I click on the left side, he should move left. And if I click on the right side, he should move right. He is, technically, but he's moving diagonally. Can you figure out why that's happening? Why do you think my character's moving diagonally? You figured it out yet? It has to do with the stuff hidden behind my head here. Remember when I put this sprite in my game, he was originally diagonal. I rotated him. So when I'm moving him left and right, he's following his rotation. Because I rotated him, he's not going left and right this way. He's going left and right based on the rotation I gave him. So how do I fix this? The easiest way for me to fix this would actually be to move the sprite as a child of another object. So I'm going to create an empty here. I'm going to call the empty player. Now, if your sprite isn't doing what mine's doing, you might not need to do this step, okay? But I definitely do because I had to rotate it. I'm going to put the picture inside of my child object. I'm sorry, inside of my parent object. So now I have player and then I have the child. We're going to take player controls off of the child object. I'm going to remove it. And I'm going to put it on the player object instead. All right, so player controls is now going on the player object. So now, when I go left and right, oh, I forgot to set the speed again. I'll put it back to 5, but I might change that later. Now he's moving left and right like I want him to. Everything looks good. Boom, boom, boom. All right, so test your program out. Make sure that your character does move left and right when you click on the left side of the screen or the right side of the screen. But we're not done yet. I want you to notice that if I hold down, he does leave the screen. So what I would need to do next is I need to create a boundary so that when he gets to the edge of the screen, he doesn't go any further. So that's going to be my next steps here. Where do I want to set the boundary to is, I guess, a good question, though. So if I'm looking at my X position, oh, it's a little wonky. Hold on. Go to scene view. Oh, my player is right there. Okay, so I need to change some stuff up because I need my player, my parent object, to be in the same position as my child object. So I'm going to need to fix some of this up. Let's set the player object's position to 0, 0, 0 for the XYZ. And then let's set the child's object position also to 0, 0, 0 for the XYZ. So now they're both in the same position. That's going to help me out a lot, right? They weren't in the same position before, and that's why my numbers looked weird. Now they're both centered. They're both in the same position. I can move the player object down towards the bottom, and he moves with it. And now when I test it, I'll be able to see the position more clearly when I'm looking at the X. All right. So what I wanted to see is where he was at when he gets to the edge of the screen. So right there, around the edge, he's at 1.9. If I go a little bit farther, he's at 2.2. And on the left side of the screen, he's at negative 2.01. So it looks like positive and negative 2 are really going to be good borders for me here. That's good for me to know. All right, so I'm going to get out of play mode. I just need to remember positive and negative 2 are the borders that I need to set up. Okay, so we're going to go back into the program here. So I've got on the game update, when I click the mouse, it moves him left or right. Everything there is working great. We're going to add another if block before the first one. So I'm going to hit enter a couple times to create some lines. And basically what I want to do is I want to look at the position of the sprite and say, if you're beyond positive and negative 2, I want you to stop moving. I want you to stay where you are. Regardless of what my other stuff's doing, I want you to stay where you are. I want you to freeze. So we're going to go ahead and set that up. So if, I'm going to put my parentheses, I'm going to put my curly brackets just to get them all set up. So if transform dot position dot x. So if the sprite, the object's x position, is basically what this is saying, is less than negative 2, that was the left side of the screen, then I need them to stop moving. So if its X position is less than -2, we're going to reset that position. So we're going to go transform dot position equal to new vector 3, and then we got to set its X, Y, and Z position in here. So its X position is going to be -2. Its Y position will be the same Y position it had before. So transform dot position dot Y, and its Z position will be the same as it was before. We're not changing those. Transform dot position dot Z, and I got to put my semicolon at the end. All right, let's test this. Control S, and we're going to see if he goes off the border. Now, we only did it for the left side, so let's see if it works. If I click on the left side of the screen, oh, I need to go in play mode. All right. There we go. He stopped at the edge. And if I look at the inspector window, you can see his X position is -2. If I keep clicking on the left-hand side, you see how his X position is trying to change, but it's not working because it keeps on resetting. So our one set of if is trying to move him to the left, but our other if is constantly resetting it. So it's not really moving. You can see it's kind of shaking just a little bit because it's trying to do both things at once, but that's fine. It doesn't hurt our program. It actually still looks pretty professional. So we're going to do the same thing for the other side of the screen. So I'm going to go ahead and copy this whole block. No reason to write it again. Hit enter a couple times to create some new lines. We're going to paste it. And this time, instead of being less than 2, we're going to go with, less than -2. We're going to go with greater than +2. So we're changing our -2s to +2. We're changing our less than to a greater than. We're going to save it. We're going to test it. If I click on the left side of the screen, he goes left and he stops. If I click on the right side of the screen, he goes right and he stops. We have ourselves some working player controls for a mobile 2D game. Congratulations. All right, this is good stuff, guys. Okay, one more concern I have, though. So I'm using the Pixel 5. What if I switched over to one of these larger devices like the tablet? When I go to play it on a larger device, it still stops at +2 and -2. Which worked great on the phone, but it doesn't really look that good on the tablet, does it? So is there a way that we could set this up so that the border is actually related to the width of the screen instead of the numbers that I set? What do you think? Well, if we look at our code, we actually have been using something for screen width down here. Here's the problem with the screen width that we've had so far. This is measuring with pixels. It is not measuring with the meters like Unity measures with. Unity measures in meters. This is measuring in pixels. So we're going to need to do a little bit of math once again if we want to set this up so it works. Up here where my variables are, we're going to create a new variable. I'm going to make it public so I can see it inside of Unity. We're going to make it float again so we can set it up as decimals if we decide to. And we're going to go ahead and call this screen. I'm going to call it screen width in meters. Which sounds weird because obviously our phones aren't several meters wide, but we're talking about the Unity meters, right? So I'm going to call it that. What I want it to do is when the game starts, it's going to measure that for us. So we're going to set this variable I just created, screen width in meters. And we're going to set it equal to the screen width. Now we can change it later, but this is just so we can kind of see. So screen dot, screen dot, why is it doing that? It's trying to replace my thing with the variable. Screen dot width. There we go. So we're going to set the screen width in meters variable, which we'll be able to see in Unity, to the actual screen width. And this will allow us to see what number it's measuring with. And then we're going to edit it. So I'm going to save this, Control S, and now let's go take a look at that. When I hit play, oh, I got an error. Oh, I forgot my semicolon. Of course. There we go. Control S. Here we are. When I hit play, notice that it filled in the information for me. Screen width in meters is 2048. So actually, that's not meters, that's pixels, right? We need to convert this to meters so that we can use it in our code. So for this game, when I had it, let's switch back over to the Google Pixel 5. In the Google Pixel 5, the edge of the screen was +2 and -2. What is the width of the screen in pixels? It is 1080. So here's what I'm thinking. I want to change this 1080 to 2. So 1080 divided by 2, what would that be? That'd be 540, right? Yeah, that should be 540. So we're going to do a little math experiment here. I'm going to set my screen width in meters equal to screen.width divided by 540. Now, screen width in meters should be equal to 2. Let's go back to the program and see. It is. It's equal to 2. Aha. All right, so why did I do that? I did that so that down here where I have my -2s and my +2s, I'm going to replace them with the variable that we made, the screen width in meters variable. I really should have come up with a simpler name. So we're going to replace all our +2s and -2s with that. And we're still leaving the positives and the negatives because those are important, right? So now it's negative screen width in meters and positive screen width in meters. All right, we're going to save this. Fingers crossed. Let's see if this works. So with my Google Pixel, it should still play the same because screen width in meters divided by 540 equals 2. So it should still stop at the edges, +2 and -2. It is working. All right, I'm going to get out of play mode. I'm going to switch to a wider device, like the tablet here. When I go into play mode now, it's going to take that original number, which was like 2,000 something. It's dividing that by 540. And look, now we have a screen width in 3. So it made our border wider. Instead of stopping at 2 meters, it's now stopping at 3 meters. Let's see what it looks like when I actually play it. All right, that's good. It's not going all the way to the edge, but you know what? I can live with that. I can absolutely live with that. Let's test it out on some other size screens. You will need to get out of play mode whenever you pick the screen you want to use. So this one is also a 2. Ooh. That one, it looks wider than a 2. I wonder why it's a 2. It's the iPad mini. I guess it doesn't have that many pixels. What about, here's a really skinny phone. This is a weird one. This one has a screen width in meters of 1. Does it play on this? It does. It still gets pretty close to the edge. It's not perfect. So obviously this is not, there's probably better solutions out there is what I'm trying to say. But for the skills that we have, for the things that we know, this is a good solution because it does change per phone. Skinny phones don't have as wide of a range as wider devices do, like tablets. So depending on the device, it is still playable on all these devices, but some of them may be better playable than others. Right now, it looks like the standard phone size is working best because you get closest to the edge of the screen, but the other ones are still playable. All right, I think we've done enough for this video. We have a working player. He can go left and right from tapping the screen, and he does get pretty close to the edge no matter what device we're using. So this is a good stopping point. All right, I hope you learned something new today. If you did learn something new, please click that like button. If you're not already subscribed, please subscribe, and I'll see you guys in the next video. Have a good one.